Okay, this is asking us to multiply out these two binomials. One way to do it is called FOIL, where we take the first terms, which are r and r. We take the outer terms, which are r and 6. Ultimately, though, that's half the story. So we'll have r times r, and then we'll have r times 6. So that's going to be r squared, and then plus 6r. Then we have the inner terms, which will be 8 times r, and the last terms in each of the sets of parentheses, that'll be 8 times 6. And so we'll have 8 times r, and then 8 times 6, giving us 8r and 48. The middle terms can be put together to give us r squared plus 14r plus 48 as the answer. Okay, that works out great when it's two binomials. A binomial is when you have two terms inside the set of parentheses. Now we have a binomial times a trinomial, 3 terms in the parentheses, and then 2 terms, two polynomial term, a 2-term polynomial. And so the FOIL only works with the binomial times a binomial. And so instead, we just take the spirit of FOIL. We take 4s times all 3. So we'll have 4s times 7s squared. We'll have 4s times negative 4s. We'll have 4s times 3. That's not the end of the story, though. We had to then go and do what was the other part of the first parentheses and distribute it. So now we have to take the 5, and it's like distributing, that's all. So we take the 5 times the 7s squared. We take the 5 times the negative 4s. We take the 5 times the 3. We have to put all these together. This is just one way to do it. Okay. We'll have 4 times 7, which is 28. S times s squared, which is s cubed. Then we have a 4 times a negative 4, which is a negative 16. S times s, which is s squared. 4 times 3, which is 12, and then an s. Then we're going to have 35 of the s squares, 5 times 3. Negative 20 of the s's, 5 times negative 4. And then 5 times 3, so 15. There's a better way we could have written it out. The terms from the second multiplications could have been written in the following way. We could have staggered it. We could have put them down here. 35s squared, negative 20s, and then had the 15. By doing it that way, what that does for us is it allows us to quickly match up terms that are alike, to add s squares with s squares and s's with s's. And so we just stagger it so that we can basically take this and look at it like we're adding vertically. So we'll have 28 of the s cubes. There's nothing to combine that with. Then we have 35 take away 16. That's 19. We'll have positive 19 of the s squares. The 35 is positive, the bigger one. And then we have 12 take away 20, because it's 12 plus a negative 20 on the s's. So that's going to be a negative 8s. You can put minus 8s or plus a negative 8s. And then we have the 15. And so that's how we get that answer. Now there's another way. You didn't have to do it that way. There is another way, but it seems to work. I'll show the other way after we're done here. And then we have our last one, 3g minus 5 and 3g plus 5. This is a special kind of factoring where the signs in between are different, but on the left and right you have the same thing. What's going to happen in this particular case is the middle terms are going to cancel out. Let's just FOIL it out. So we take the first guys, which is 3g times 3g. We take the outer guys, which is 3g times 5. Then we go move to the inner guys. We take a minus 5 times a 3g. And then we take a minus 5 times a 5 for the last terms. So we have 3g times 3g, 3g times 5, put a plus sign in between. Keep the plus signs in between, and just keep copying down the terms. Just keep it easier for yourself. And now we're going to have 9g squared plus 15g minus 15g minus 25. These middle terms cancel out. So we end up with 9g squared minus 25 as the answer. Now let's revisit that first one. I'm sorry, the second one. Let's revisit number 10. I'm going to do it a different kind of way. It was 4s plus 5. And then it was 7s squared minus 4s plus 3. I just want to show you an alternative way. I learned this from one of my students. You could actually do all these this way if you like. If you're somebody who likes structure, this works nicely. You take the terms from the first one, either put on the row or a column. So 4s and 5 or 3? 5. Okay, 5. And so 4s gets its own row, 5 gets its own row, and then 7s squared gets its own column, negative 4s gets its own column, and 3 gets its own column. This is like setting it up like an Excel kind of problem where you have rows and columns, and we're gonna multiply. And so anytime any of these two guys cross, we multiply. 7 times 4 is 28. S times s squared is s cubed. Then we have 4 times negative 4, so negative 16. S times s, so s squared. 4 times 3, so 12 with an s on it. Then we have a 7 times 5, sorry, that's a 35. This is a 5, so that's a 35 with the s squared. Then a 5 times a negative 4, that's a negative 20 with an s. And then 5 times 3, that's a 15. And what's nice about this way is when you go to combine the terms, they combine nicely along diagonals. Your s squared terms are here, and your s terms are here. And so this sort of row and column multiplication way works out nicely. It gives you the answer rather quickly. 20s s cubed, and then we get the 19s squared again from these guys. 35 take away 16, and then we get the negative 8s from these guys. Negative 20 add on 12, and then plus the 15. So it's an alternative approach. It's row and column, kind of like Excel, and working it out that way. Even the binomials can be done that way. All right, that's it.